Aloha and welcome to our video on ocean circulation. In this video, we'll explain how surface currents develop. We'll describe how ocean currents can affect climate. We'll state the importance of upwelling, and then we'll describe the formation of density currents. Okay, so let's take a look at our ocean surface currents. And as we look in this diagram here, you can see that we have several different named currents. These are the big ones that are always going to be flowing. Now, currents are going to be primarily formed from two reasons. It's either going to be wind, okay, which are these large surface currents, and then when we talk about some smaller currents, we'll talk about how waves can induce a current as well. But for the most part, these are going to be generated by surface winds, and our surface winds are going to be influenced by what we call the Coriolis effect, and we'll talk about that a little bit more in the next slide. But what you'll notice is, remember, the Earth is always spinning. So as the Earth is spinning this way, what we're going to notice is where you have an area where there's not a lot of winds, as the Earth is spinning, it's going to leave the water behind, and that's what we notice here at the equator. And all of the equator, we're leaving that water behind as the Earth is spinning, and that causes the equatorial currents. And most of our equatorial currents are going to be flowing from east to west. Now, as these equatorial currents, and let's just focus here in the Atlantic, it's going to travel this way, it's going to run into South America. And as it runs into South America, that's going to cause it to bend around, and we end up going up the coast of North America with a warm current. So we're going to have warm water from the tropics coming up along the coast of the Americas. And then that's going to shoot across the Atlantic where it'll cool off, but it's still relatively warm until it gets cool up here into the North Atlantic, and then we'll have a cold water current travel down, and you can see how we form these circles or these gyres, and this is the North Atlantic gyre. So on the Atlantic Ocean, we have this warm water traveling up, so our beaches are going to naturally be a little bit warmer, versus if we go to California, where we're on the east end of the basin, we'll notice that warm water is traveling up across here, it's cooling off, and we have a cold water current coming along California, and that's why the waters in the Pacific, on our Pacific coast, are going to be a little bit cooler. And we can see that that'll come down, the Peru current will come up, those will collide, and that's what causes the equatorial currents to be moving from east to west as well. Okay, so let's talk about the Coriolis Force. The Coriolis Force is an effect of the Earth rotating, okay? So if we take a look at a non-rotating Earth, if I had a projectile like a baseball and I threw it from the North Pole to the equator, it would travel in a straight line. It would travel straight south to the equator, okay? And that's what we would see. However, we have to remember that the Earth is rotating. So remember that it's going to rotate this way. As it does so, that non-attached particle, that baseball, is going to have this bend in its motion. It's apparent. It's still going to travel in a straight line, but it's going to look like it's bending this way because the Earth is rotated around it. So here, while I was throwing it and aiming for the target, in the time that it got there to go, the Earth had rotated 15 degrees, so it gives an apparent motion that it is bending or curving like this. And in the northern hemisphere, it's going to curve a little bit to the right. So if we take our map, and this is going to be a really crude map, here's North America, and over here is going to be Europe, okay? Remember we talked about our currents, okay? So we have this warm equatorial currents caused by the Earth rotating. Remember, the Earth is going to rotate this direction, so this water is left behind because water is not attached to the surface, so we get this westerly looking current going here. Then it's going to slightly curve to the right, so in reality it's going to kind of go like this. So now we can see why it goes up the coast of North America, and as it travels up the coast of North America, that Coriolis effect is going to cause it to bend a little bit to the right, and it's going to travel across the Atlantic Ocean here, but really it's going to kind of have that curve still. And here we get cooling off, we get this cold water current going down, and that's going to kind of turn like this, and that's how we build our North American gyre. Okay, this current in North America, this one right here that we see coming up, we call this the Gulf Stream. And let's take a look at the Gulf Stream. So in this picture here, let me show a couple things. Here we have New York, here we have Washington, D.C., here we have Norfolk, Virginia. So we can see the coast of North America. We have this cool water from the north that's kind of trickling down this way. But we have this warm tropical water coming up, and this is what we see as the Gulf Stream. And you can see how it's going to carry this water across. Okay, it's going to cool over time, of course, but as it's traveling across the ocean, you can kind of see this warm, this severe temperature variant. So we have this warm water that's flowing, and that's what we call our current. So we can see where the Gulf Stream is by looking at temperature that way. So here what we notice is we have our major ocean surface currents. Each of our oceans are going to have a gyre system in them. The Indian Ocean gyre will be here. The Arctic Ocean gyre is here. The North and South Atlantic, because they have this equatorial current going on, you'll notice there's a North Atlantic and a North Pacific gyre and a South Pacific and a South Atlantic gyre. And you can imagine the water temperature is going to be based on where it's at. So if we look at the Indian Ocean gyre, you have this cold water flowing up this way. You can kind of see this cold water flowing up this way from the Antarctic region. As it gets into the tropical region, it's going to warm up. Now we have warm water, and that warm water is going to flow down and either come around this way and cool off again and continue this Indian Ocean gyre, or some of it will escape out this way, and then we can see that it'll move that way. And we'll talk about how all of these currents kind of tie into each other a little bit later on. Okay, so let's take a look at upwelling really quickly. Upwelling is going to be caused primarily by these surface winds, and these surface winds are going to take this warm surface water and it's going to blow it away from an area. And as it does so, it leaves behind this little empty space. So this little emptiness is going to be here, and the only place that we can replace that with is going to be this deep, cool water is going to get pulled up into this space. So you can kind of see how that cycle will continue there. So as these surface winds are blowing, this upwelling occurs, and upwelling is where we're taking this deeper, colder, nutrient-rich water and we're lifting it up to the surface. And that allows for these nutrients to be there, and we can see phytoplankton now has the nutrients, so we can see photosynthesis occurring. So where we have upwelling, we generally will have areas where we have an increase in productivity because we're bringing up these nutrients for photosynthesis to occur. Okay, what this picture is going to show us is going to show us some of this deep water circulation caused by density. And if we notice, we have this warm water up at the surface that's going to cool. And as it cools, we're going to notice that it becomes more dense. It's going to plunge downwards. And as it plunges downwards here, what you'll see is it'll run into several different things. In the Antarctic, this is the south here, our Arctic is the north up here, we have this really cold water that's always going to be cold. And we'll notice that this water here is going to flow and kind of try and fill the ocean's bottom this way. When we have our Arctic waters are going to collide into this, and it's going to cause it to kind of move upwards. And as it does so, some of it will cool here and it'll form into this Antarctic bottom water, but some of it will come up and it'll form this Arctic intermediate water level here. So now we have it warming up, and as it warms up, it's going to get cool again and come down, but we'll also see this area here that's going to start to circulate as well. So we can have deep water movement of water, mid-waters movement, our surface waters at the equator. What's going to happen is we get wind currents, surface currents, and that's going to push this water up to the poles. As it pulls up this way, it's going to cool, and that'll cause a downward flow and cause this circulation. If it gets further to the poles, it'll cool further, become more dense, and cause it to sink a little bit more rapidly. So we get this mixing going on at the ocean. Primarily at the poles is where we see a lot of the mixing going on, or in these higher latitude levels. And this is where we kind of saw that earlier, where the ocean tends to be like a uniform layer at these points here versus these strict layered out regions that we see down in the tropics. Okay, in this picture here, we're going to look at this conveyor belt model of ocean currents. And what that means is that all of the ocean currents kind of tie into each other. And what it allows is it allows for global circulation. So if we start off here with a surface current off the coast of California, what we'll notice is that surface current can take it out through into the Indian Ocean, and in fact through the Indian Ocean and up to the North Atlantic, where it'll cool off. When it gets to the North Atlantic and cools, it becomes a little more dense, becomes one of these deep water, subsurface density currents that flows underwater, and this can actually carry us back to the Indian Ocean, and then we can join again, or it could carry us all the way over back into the Pacific Ocean, and we can see joining back with surface water. So you can see how the entire oceans are connected by these warm surface currents and these cooler subsurface flows, these underwater currents, and how they all tie together and they can mix for the entire ocean. So we can see how water can travel from one to the other. They're not isolated areas. Okay, so that's it for our video. As always, good luck on your quiz, and we'll see you in the next video.